Okay, so in this video I'm going to show you how to create a standard wheel for your Sumobot that is parametric, and we'll see what that means in a minute here. You can design your wheel however you want. This is just an example of how to design a parametric wheel. One thing I do recommend is that while you can see I'm designing this in its own file here, I recommend that you build this in the sort of larger file that you're creating all your main file for your Sumobot. So everything is built in the same place and not to separate them out like I'm kind of doing here. I'm only doing this for instructional purposes. So you can do this, but I don't recommend you do. So anyway, let's get started. I've already gone ahead and saved this file, and I've gone ahead and created a wheel component in it. And additionally, I've already gone ahead and created some parameters. And I'm going to open up the parameters menu here for you. And you may want to stop the video at this point and maybe copy these down in your notebook so you have them. But these are the ones that you're going to want to have in there. We've got what's called a torus diameter. You'll see what that means, but that's the rubber tire, and it's the diameter of the sort of black rubber tire. The tube diameter, that's the sort of diameter, the overall diameter of that tube, not just the sort of thickness of it. And then the number of tubes. So students sometimes vary on how many sort of rubber tubes they have on their rim. So this will allow you to change that. And this is the sort of tricky one that allows this all to sort of happen. I call it first space. There's some issues when we're trying to do multiples of things with odd and even numbers. And so this first space is going to allow that to work correctly for us. Now we're using an if statement for this. You do need to, there is some ordering here, so do first space last because we're using tube number and torus diameter contained within it. So if you haven't created those three yet, then it won't let you write this function. So create these first, and then you can go ahead and do write this down. But what we're basically saying, if the tube numbers, so the number of tubes modulo, so that's division, and we're just looking for the remainder. So if the remainder of dividing something by 2 is greater than 0, then we're going to basically be 0. And that's 0.0001. It doesn't let you make this 0, so that's why I have this kind of strange number in here. And so otherwise, if that's not the case, then the distance will be the torus diameter divided by 2. And that'll make sense in a second here when you see what we're doing. So let's go ahead and get started. The first thing we're going to do is create an offset plane. I'm going to do it here. And the distance we're going to write in is first space. Okay. So now I've got my offset plane that's first space. Next, we're going to create what's called a torus. A torus is this circular object, it's basically like a wheel. So let's go ahead and look for torus. Here we go, found it. And so torus is going to ask us to choose a plane, and so we want to make sure we're choosing that first space plane. So you can turn off any of the origin stuff just to make sure, because it's right there. It's really close, and I think I just selected it. Hopefully. We can see here. Yeah, so that should be it. And so now I'm going to go to the origin, and you can just click up, and it doesn't matter what we set this to right now because there's a dialog box that'll pop up in a second. So I'm just going to click to set it, and then here now we can see that dialog box. So now let's fill this in. So torus diameter, well, that's easy. That's going to be torus diameter, what we've set. And then the inner diameter, we are going to set that to tube diameter, which is basically 3 right now. And then instead of on center for the position, we want to have it set to inside. And now you can see that the tube is on the inside of that outer diameter. So we know that at its largest extent, it's 3 inches from here to here. And that's what we're looking for. And we'll let it be a new body, and we can go ahead and click OK. Now the next thing we can do is let's add. So basically all we do is we've got one of these, right? So here you can see, let's just change this to 2. All right. Well, that doesn't do anything because we need to multiply it. So let's actually change it back to 1. So let's go ahead and do a rectangular pattern. We'll choose body, we'll choose it. Axis, we'll choose the x-axis here. And we'll change the distribution to spacing, the quantity to tube number. Distance will be torus diameter. And direction will be symmetric. And then axis 2, we can just change this to 1. We're not using it, so it doesn't really matter. And we'll click OK. Now when we go into our parameters, let me make this a little smaller here for you. A little smaller. We'll move this over here. If we change this to 2, we should get 2. Now that's all good, and we can see that the center of it is right here. And we want that to be basically the origin point. Let's see here. Hold on. I'm going to turn this off. There we go. Okay, so we're going to just go ahead and check this again. If we come to our parameters, and I change this. Let's change this to the front view. All right, so let's change this now to 2. Perfect. And we can see it's staying centered on the origin, and that's what we're looking for. Now, if I change this to 5, again, now it changes so that this tire is centered on it, as opposed to when it's even, it splits the tires, right? So there's not one centered on it. That's what I'm looking for. Now, I had a bit of an issue. I don't know why, but sometimes you need to make it negative so it moves in the right direction. So here I just changed this 2 to a negative. I've made this before where that's not the case, so I'm not 100% sure why that sometimes happens, but that may be something you need to look at to make it function correctly. I'm just going to go ahead and set it back to 1 now, and we'll hit OK. And then we could call this, I like to just call it something like rubber, because that's what it is. I'll turn the origin off. All right, so the next thing, I want to make the rim, so the part that holds the tire. And in order to do that, we're going to create a sketch on this plane here. And we can leave the tire in for now. I'm just going to draw some sketch lines, and then we'll dimension and get them all set up in a second. So let's go. Actually, let's draw this to be tube diameter. I'm going to add the dimension now, sorry for this one. Divided by 2. Actually, let's change that to, we'll add these. I'm going to add, sorry about this. We're going to add these parentheses in here because I want tube diameter divided by 2, and then I want minus torus diameter. So let's try that. That's better. So that gives me something that looks like this. Now we'll go ahead and I'm going to just draw. I'm just randomly kind of drawing these. Maybe to here, 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 and over to that. Whoops, get this over to here. We got a closed thing now. Now we're gonna go ahead and add some dimensions to this. So let's see here. Okay, so we've got kind of drawn it out here in this basic shape. It's an enclosed area here. So let's go ahead and kind of figure out the rest of it. One other line I am going to put in here. Let's go with, whoops, get the line tool going here. I want this line to be torus diameter divided by 2. That's going to give us kind of this midpoint area right here, and that's what I want. When you draw these lines kind of out like this, it's good just to make sure that they're straight up and down. This one doesn't look like it, so I'm just going to select horizontal constraint, and now it is. It's turned black. This line here, let's go ahead and give it a dimension. This will be an important dimension. So we'll start with a parentheses here. We're going to say that this is going to be the torus, or it doesn't matter, I guess. Tube number times torus. The torus diameter. Close that parentheses, and we'll divide that by 2. Now I want to use some constraints here, so I want to constrain this point to the height of this point, so let's go ahead and do that. And I want to constrain this point to this point. And then I want this angle to always be a 45-degree angle, so I'm just going to go ahead and make that 45 degrees. Perfect. And that's all we really need to do for that. You can see it is fully constrained. And if I go ahead, so we go ahead and change our tube number now. Let's go ahead and make that 2. We should see the sketch change this distance as our tube numbers are changing. So we know that this is all changing correctly, even if let's make it 6. Perfect. It's adjusting accordingly, and that's exactly what we're looking for here. Going back to 1, I'm going to hit OK. And we can go ahead and now finish the sketch, and we can revolve this. So we'll revolve as a new body. You can see this is already selected. The axis will be our x-axis. All of these are just perfect here, and I'll go ahead and click OK. And so now we've basically got one half of that. In order to create the other half, I'm just going to simply use the combine, or whoops, not the combine tool. I'm going to use the mirror tool. So we'll go ahead and mirror this. So I'll mirror this body. The mirror plane will be this mirror plane here. We'll leave it as a join. And perfect. Now we've got a new body that we can call rim. And you can see if I remove this, we still have the tube. If I close that, we've got this guy. Now, one thing I do like to do for this is just give a nice fillet to these interior corners here. So we're going to actually, what I'll do is I'll roll this back before the mirror. So right to this point, we'll go ahead and come back in. We'll add that. I'll call this torus diameter divided by 2. That'll give us perfect fillet for the actual tube. If I turn that back on, it's going to fit in there perfectly like that. And now we can roll the timeline forward down here, and we've got both our halves. Perfect. And if I go ahead and inspect this with a section analysis, turn it around here, you'll see that fillet makes it perfectly fitting the tube there. So that's exactly what we're looking for. Turn that analysis off. So the next things to do here is to create the part for the axle to connect the axle of your motor to the wheel. And there's a few ways to do this. I'm not going to cover that in this video. The other thing you can do is add some, design or weight saving parts to this. A normal wheel might have some holes in it, spokes and those kinds of things. And you can go ahead and do that if you'd like. The way to do that is to draw one kind of part of it and then create a pattern. Maybe I'll do that in a different video. But anyway, this is how you create your parametric wheel. We can go ahead and add, let's see, I'm just gonna give it some color here. Let's go to plastics, nice. Opaque. So I'm gonna put that up in there, maybe the white up in there. So now I'm just gonna paint that rubber white or black, and then the rim can be white. There we go. Now we've got a nice parametric tire. And again, if I go ahead and change my parameters here, we should be seeing this tire changing. Oh, perfect. Look at that. Exactly what we're looking for. All right, so that's how you can make a simple parametric tire. I'll create another video going over some more aspects of creating the other components of this tire. Thanks for watching. It's a tough video.